everybody, this is Miss Dietrich. We're taking a look at lesson 9.5, which is on equations and graphs. Each of you has your own Jamboard for lesson 9.5, and the first slides that you're going to be looking at will actually be your homework. So that would be slide number 1, slide number 2, slide number 3, 4, 5. So slide number 6 is the first one we're going to be doing in class. Now I'm going to be using a different software. I'm going to use my Smart Notebook software just because it is a little bit easier for me. But you're just going to follow along on your Jamboard. A blue whale is swimming at an average rate of 3 miles per hour. Write a linear equation that gives the distance y in miles that the whale swims in x hours. Then graph the relationship. All right, so we already know the function here, which is 3 times x. And they give us the example of substituting in a 1 for the place of x. And if we do 3 times 1, we would get 3. So our ordered pair would be 1, 3. And if we plot that, if we go over 1, remember the first number in an ordered pair is the x coordinate, and the second one is the y. So let's just put that little reminder here so we remember. All right, so if we go over 1 and up 3, then we're looking at this dot. This one's plotted. All right, now if we substitute the number 2 into the place of x, then we're really doing 3 times 2, which would be 6. 3 times 2 is 6, so our y coordinate would be a 6. We would go over 2 and then up 6 and make a dot. All right, so the next suggestion for what to plug in or substitute in for x is the number 3. So that means we're going to do 3 times 3, and if we do 3 times 3, we end up getting 9. So our ordered pair would be a 3 and a 9. 3 and a 9. Let's go over 3 and up 9, which should be about right here. Make a dot. All right, our next ordered pair, we're going to take the 4 and substitute it in for x and do 3 times 4 to get 12. So we're looking at 4 and 12 as our x and our y coordinates. All right, so we're going to go over 4 and up 12. All right, now we can use this. You can see that we're starting to form a linear. It's linear, it forms a line. So I'm going to use my little line tool, and I'm going to connect the dots. And we can use that to make predictions. And by the way, it's always a good idea to make sure that your line, it should really go all the way to the bottom corner and all the way through your graph. And then to make it complete, we usually like to put arrow tips on it, like so. All right, so there's our graph. All right, let's take a look at the next question. This is slide 7, by the way, on your Jamboard. It says, the graph shows the number of beaded necklaces Y that Ginger can make in X hours. Write the linear equation for the relationship shown by the graph. All right, and they give us these points. So what we need to do is we need to make a t-table. I call it a double t-table because what I like to do is I like to try to figure out what the function is in the middle. So that first ordered pair is a 0, 0, so we put in a 0 and a 0. That second ordered pair, the x is a 1 and the y is a 2. So let's plot this one as well, or not plot it, but rather put it in the table. So the x value is a 3 and the y value is a 6. All right, and over here we have the x value as a 4 and the y value is an 8. All right, so really what we need to do is we need to figure out what do we do to this number to get this number? And it has to be the same thing for each time. So it kind of looks like the numbers are getting bigger, right? These numbers are bigger than the numbers over here, which means we're either adding or we're multiplying, or perhaps a combination of the two. So it looks to me like we might be multiplying by 2. See, this times 2 would be 2, 3 times 2 would be 6, 4 times 2 would be 8, and 0 times 2 would be 0. So how would we write that? We would write it like this. The function would be 2 times x. And remember, that's going to equal the y. So if we need the entire equation, see how it says the linear equation for the relationship is y equals? It would be y equals 2x. But I usually like to write it, for some reason, I like to write the equals y after, so it's the same thing as 2x equals y. All right, but we need to finish the table. So we would do 2. Each time we're going to be multiplying 2. And in each case, we would substitute in the value for x. So let's do that. The value for x here is a 0. 2 times 0 does equal 0, so it works there. The x value is a 1. 2 times 1 would be 2, so it works there. Let's substitute in the 3. 2 times 3 is 6. Substitute in the 4. 2 times 4 is 8. All right, so our function is 2x. All right, let's look at another example. This is slide number 8 on your Jamboard. All right, so this time I want you to graph the linear equation. All right, now notice when we think about what can we graph on here, we don't have negative numbers. It's not one of those ones that has the 4 quadrants. So we're not going to use negative numbers like you might when you're in 7th or 8th grade. We have to stick with numbers that fit on the graph. So what numbers might that be? Also, another thing I want to remind you about, whatever number we try for the x value, we want to be able to easily subtract 2 from it. So I'm going to suggest that the first value we try is a 2, because if we substitute that in, then we don't have to deal with the negative numbers and we'll be able to plot that on the graph. If we do 2 minus 2, that'll be 0. All right, so if we think about that as an ordered pair, that's going to look like this, right? 2 comma 0. And we can plot that. We can go over 2 and up nothing and plot that. All right, so other numbers that might be easy to subtract 2 from might be like a 3 or a 4. So let's just put in things that are easy to subtract 2 from. And really, what's the minimum number of values you should come up with for the x? You really need a minimum of 3. I'm going to suggest 4 or 5 just to make sure that you don't have anything that's a little bit off, and that'll make more sense when we go through plotting the actual points. All right, so what I like to do is I just like to copy the minus 2 and just because I don't want to make a mistake, copy that as many times as you need. And then let's make sure we understand where we're pulling this number from. See, we're substituting in what we're using for x, for the place of x. So that means we're going to put a 3 here. We're going to put a 4 here. We're going to put a 5. And we're going to put a 6. All right, and perhaps we should extend this line a little bit. Let's extend this line. All right, and let's come up with our y values. So over here, if we do a 3 minus 2, that's easy enough. That's going to give us a 1. 4 minus 2 would give us a 2. 5 minus 2 would give us a 3. And 6 minus 2 would give us a 4. All right, so if we kind of finish plotting this, see, this is going to give us the ordered pair of a 3 and a 1. Let's plot 3, 1. Over 3, up 1 would be here. Here we have the ordered pair of a 4 and a 2. And if we plot that, we have to go over 4 and up 2. And here we have the ordered pair of a 5 and a 3. We'll go over 5, up 3. And then let's plot this last one. It's 6 and a 4. And if we plot that, we're going to go over 6 and up 4. All right, and then if you're using digital stuff, and it's a little bit easier to draw a line, but if you're actually graphing this on paper, then you would want to use a ruler to connect your points. Now, one of the things that I just want to discuss is the idea of what if you plotted your dot and you had a dot that was not lined up, like you had a dot that was over here and all of your other dots lined up, then that would suggest that you want to go back and check to see if you had made a plotting error, because usually that's what that does mean. Now, the other thing I should mention is that we can take any point on this line that I just created. So let's give you some examples. This point right here that I'll put in green, this point, or even points that don't fall on the intersection, right? We could even talk about a point right here where the tip of my pen is pointing. Those would all, if we substituted those into the table, they would all work. All right, so we have our graph. And by the way, what mathematicians usually do is they often will write what the equation is right on the line, especially if you have to use the same coordinate plane for multiple lines. So that's a good habit to get into. All right, let's look at slide number 9 on your Jamboard, which is y equals 3x. All right, so again, we want to think about values that will fit on the coordinate plane. We don't have any negative numbers here. So we have numbers like 1, 2, 3, 4. And we also want to consider the fact that we're going to be multiplying by 3. And we want it to fit. If we multiply it by 3, we don't want to pick big numbers, because let's say we pick the number 20. 20 times 3, we don't have that number on the y-coordinate, or axis rather. It won't fit. So we have to choose things that will fit on the graph or on the plane that they give us. So what am I suggesting? I'm suggesting trying numbers like a 0, a 1, a 2, maybe a 3. You really should have a minimum of 3. 4 is better. 5 is even better, but I'd say 3 or 4 is a good minimum to go with to get your line formed. All right, so now we're going to go ahead and substitute in. So let's start by writing the 3's in a set of parentheses. Now, the reason that I like to do it this way is because you get into a groove and you're less likely to mess up with the number. So we just copy that. And then once you do that, then I like to go back and substitute in the number. Substitute in the number for x, substitute in the number for x, substitute in the number for x. So if you get into a rhythm, it makes it so that it's kind of automatic for you. All right, and now let's figure out the y values. So if we actually multiply 3 times 0, because that's what that means, multiply, we'll get a 0. If we do 3 times 1, we'll get a 3. If we do 3 times 2, we'll get 6. And if we do 3 times 3, we'll get 9. All right, so if we think about the ordered pair, see we have the x here and the y here. So as an ordered pair, that would be a 0, 0. In other words, the origin. This ordered pair would be a 1 and a 3, 1 comma 3. This ordered pair would be a 2, 6. And this would be a 3 and a 9. All right, now some people don't actually have a need to write the ordered pairs because they're able to deal with the fact that they're separated by the work in the middle. And if that's something that you can get away with by just looking at the table and plotting it right from there, then you might be able to skip this step if there's not a white space for you to fill in. All right, but now let's start plotting. So we're going to plot this point first, which would be at the origin, 0, 0. So that one's done. Let's plot this one. Go over 1 and up 3. Over 1, up 3 would be right here. That one's done. All right, over 2, up 6. Over 2, up 6. It's going to go right there. So that one's done. And over 3, up 9 would go right here. All right, so once we have all of our points, then you use your line tool or a ruler if you're doing this on paper, and you want to connect your points. And they should line up and go all the way through your graph. And then let's put the arrow tips on the end. Now, if this was a 4-quadrant plane, we might put the arrow tip over here, but it's not. So we'll just leave that as just a, we'll call it a ray instead of a line segment. All right, so there's our line. And what do people usually do? What do mathematicians usually do? They usually write the equation. So we have 3x equals y. And where am I pulling this from? I'm pulling it from right here. So 3x equals y. I just throw in an equal sign there. See, that's the same thing as this. All right, so that one's done. Slide number 9 is done. All right, now let's look at slide number 10 on your Jamboard. Slide number 10, it wants you to write the linear equation for the relationship shown by the graph. Now, in this case, when you're working from a graph, then you want to substitute, you want to put in the points in your table. So do you see how here this first point is 2 over 2 up 1? So you would write that in your table. This point right here is 4, 3. By the way, we could have put this point in the table right here. We could have because it does fall on the line. But this one shows 4, 3, which is fine. And then over here, we have 6, 5. So let's fill that in. 6, 5. And then over here, we have an 8 and a 7. All right, and again, there are other points that we could use. For example, that right there. We could use that. We could use this point right here. So if we get stuck, maybe we can go back and look and see what those ordered pairs are and put them in the table to help us identify what the function may be. All right, so if they want the linear equation, we have to figure out what are you doing to the x to get y, and it has to be consistent for each ordered pair. Now, it looks like the numbers are getting smaller, doesn't it? When they're getting smaller, you want to explore the idea of maybe subtracting, maybe dividing, maybe a combination of those things. But doesn't it look like we might be subtracting by 1? So let's try that. We might be taking the x and subtracting it by 1 to get the y. So that would be our equation, right? X minus 1 equals y. So let's give it a try. By the way, always a good idea if you're using paper and pencil, never use pen, because sometimes you realize that you haven't made the right choice with the function, and a lot of times you have to erase it, so you'd want to lightly pencil it in if you're not using a Jamboard where you can easily erase it. All right, so if we substitute in all these values, but I like to get in the habit of just copying the -1, the -1, the -1, and the -1, and then pulling the x values from here. So that's a 2. Here we have a 4, a 6, and an 8. All right, and then is 2 minus 1, 1? Yep. Is 4 minus 1, 3? Sure is. Is 6 minus 1, 5? Yep. And is 8 minus 1, 7? Yes, it is. So we found the function. And if they want to know the equation, then you have this whole thing would be the equation. The x minus 1 equals y is what you want to put on the answer space for the actual equation. So if they just want the function, then you just put x minus 1. But if they want an equation, remember equation, you have to have an equal sign. Then you need to include that it equals y. All right, so I think we're ready to move on to slide number 11. It says write the linear equation for the relationship shown by the graph. And we have these points now. So let's start by looking. This has 2, 1. That matches up with this point right here. That's already been put in the table for you. But let's continue with the next point that they give you, which is right here. It's a 4 for the x and a 2 for the y. And then the next point that they give us is a 6 and a 3, followed by an 8 and a 4. All right, and we need to examine what are we doing to this number to get this number? What are we doing to this number to get this number? Now, the numbers in the y column are less than the numbers in the x column, which means we might be subtracting, we might be dividing, perhaps we're doing a combination of things. But this one seems kind of simple because it looks like we're dividing by 2 to get from here to here. So let's try that. We're taking the x and we're dividing it by 2 is what we think is going on here. By the way, I should mention that another way you might see that is you might see it written like this. Half of x. Did you know taking half of x is the same as dividing it by 2? Or another way you might see it is x divided by 2. These 3 things that I have, the purple, the green, and the red, are all the same thing. So let's work with the red version just because it's just a little more user-friendly. So let's use that. And let's plug in the values and make sure it works. All right, so if we write the divide by 2 all the way down for each one, all right, so it's just simple copying. You're just copying. Here you're writing the value that you put in for x. So we have a 2. Here we have a 4. Here we have a 6. And here we have an 8. And let's just make sure that the value that we have for y would be the quotient. Is 2 divided by 2 1? Yep. Is 4 divided by 2 2? Yep. Is 6 divided by 2 3? It sure is. And is 8 divided by 2 4? It is. So we found the function. Now they want the linear equation. So you need an equal sign. And you need to write this whole thing. X divided by 2 equals y is your linear equation. Now remember, that's the same thing if it's a multiple choice test and that's not offered as a choice. Don't forget x divided by 2 can look like this. X divided by 2 equals y. Or let's say that's not a choice and it's multiple choice. Don't forget half of x equals y. These are all the same thing. So if you're looking for the answer and this is not offered and this is not offered, but this is, then you would pick this. All right, let's move on to slide number 12 on your Jamboard. Graph the linear equation. All right, so they give us the equation. Sometimes that's easier. And you have to create some values for x. Now remember, x, you want to make sure it's going to fit on your coordinate plane if you have to graph it. So that means we don't want to choose anything higher than a 10 and we don't want to choose anything lower than a 0. But since 0 is pretty easy to work with and we can add 1 to it easily, let's try a 0. How about a 1? How about a 2? And maybe even a 3. All right, so the next step is to just go ahead and copy that +1, +1, +1 all the way down for each value. And then for here, we have to be careful because we just have to take this number and put it here, take this number and put it here, take this number and put it here, take this number and put it here. And then to get the y value, we're just adding these two things because remember, this is an equation, right? This part right here is the equation. So that means we would have to add these two numbers to get the y, which would be 1. Here we add these two and get the 2, add and get the 3, add and get the 4. All right, so now we have the ordered pair of a 0 and a 1. A 0 and a 1. So we go not left or right, but up 1, which should be about right there. We go over 1 and up 2. Over 1, up 2. So that's right there. Over 2, up 3. Over 2, up 3 would be here. Over 3, up 4. Over 3 and up 4. All right. Now, if we had chosen other numbers, then we would have been able to fill up more of this graph. But we're going to still fill it up because you don't want to just connect your dots that you have and just leave it at that. You want to have the line go all the way through because then you're able to use your graph to help you make predictions about other points. So a good example is this. That ordered pair would go with this equation, right here, this. There's a bunch of points on here. And some people like to actually write the equation, which is x plus 1 equals y, right on the line. Not always a requirement, but if you're doing multiple lines on one coordinate plane, then that's when you definitely would want to label. And just to be completely correct, we like to put that arrow tip on the end. All right, so we're wrapping up here. Let's look at number 6, getting a little more complex with 2 steps. So this one has multiplication and it has subtraction. And they do want you to graph the linear equation, so it's a little more complex. Now again, when we think about x values that we're going to put in here, we want to think about things that would be easy to multiply with 2 and also subtract 1. So I don't see any reason why, if we put in a 0 here, then we're talking about negative numbers because a 0 minus 1 would be a negative number. So let's not use a 0 because it's just going to be a little bit of a headache. Let's start with numbers like 1, 2, 3, and 4. All right, so if we substitute in a 1 here, 2 times 1 would be 2. And if we subtract 1 from 2, we're going to get 1. And if we substitute in the 2 right here, 2 times 2 is 4. 4 minus 1 would be 3. Substitute in the 3 for x. 2 times 3 is 6. 6 minus 1 would be 5. And substitute in the 4. 2 times 4 is 8. 8 minus 1 would be 7. All right, so now we're ready to plot our ordered pairs. Now again, if you want to write the ordered pairs, see I'm just pulling this from here and from here, 2, 3, you're welcome to write them, but you don't always have to do that if you're able to. If they just want you to graph it and there's not a white space requiring that you write the ordered pairs, then you might be able to skip this step that I have written here in green. So let's go ahead and plot. We have over 1, up 1. Over 1, up 1 would be right here. If we go over 2 and up 3, over 2, up 3 would be here. Over 3, up 5. Over 3, up 5 would be here. And over 4, up 7. Over 4, up 7 would be here. All right, now let's use our line tool to connect our points. Now remember, it's not good enough just to leave it at that. You want to have your line go through everything. And also, I like to have the line even on the bottom. I like to have the line go down all the way to where the X line is in this case. And then put your arrow tip on there. And then another nice thing to do is to take your equation, which I have right here. I'm going to circle in yellow, which is the same thing as this. It's just putting the y on the other side. And we usually like to write the equation right on the graph. So that's 2x minus 1 equals y. All right. Next slide, number 7 from your Go Math book, or slide number 14 on your Jamboard. It says, the graph shows the number of loaves of bread, y, that Kareem bakes in x hours. Write the linear equation for the relationship shown by the graph. So they give us a little blue space to put the linear equation. So again, if we plug in numbers here, it's been started for you. We have 1 and a 1, We have a 2 and a 2, a 4 and a 4, and we have a 5 and a 5. So let's slip in that 5 and the 5. And we have to ask ourselves, what do we have to do to the x to get y? What do we have to do to it? Because we need a linear equation. So x, do some stuff to it, and get y. Now, doesn't it kind of look like it's multiplied by 1 maybe? So let's try that. If we do x times 1, that could potentially work. Or is it x plus 0? Because if we add 0, could that potentially work? All right, but let's start with this, because you want to think about the situation too as you're trying to figure out which equation really makes the most sense. So remember, the x is ours, and the y is representing the number of loaves of bread. So sometimes it's a good idea to label when you have a situation what things are to help you understand. So it kind of looks like we need the full hour to make 1 loaf of bread. We need 2 hours to make 2 loaves of bread. We need 4 hours to make 4 loaves of bread. So doesn't that kind of seem like it's 1 loaf per hour, which would suggest that we're going to be multiplying these two things together. So let's just double check. So if we do a 1 times 1, that does equal 1. If we do a 2 times 1, that does equal 2. If we do a 4 times 1, that does equal 4. And if we do a 5 times 1, that does equal 5. So if we're talking about writing an equation, it might just look like this, right? 1x equals y, or even just x equals y, right? If we want to simplify it, x equals y. It's the same thing. All right, let's move along to slide. I think this is slide number 15. So this one does give you the idea of fractions, but I do want to remind you that taking half of x is the same thing as dividing it by 2. So let's take a look here. They want to know, does the graph represent the equation? So what we would want to do is we'd want to take our points here that are given. So we have an x, we have a 2 and a 3, we have a 4 and a 4, and we have a 6 and a 5, and we have an 8 and a 6. All right, so let's see if we substitute in the values. So I'm just going to leave a set of parentheses like this. And then what I'm going to do is I'm going to clone what I just wrote, kind of a way that I cheat a little bit. So I'm going to just keep cloning this so I don't have to keep rewriting it. Clone it again and clone it again. All right, and what we'll do is we'll substitute in the value for x. So here we have a 2. Now if we think of what's half of 2, and if we add 2 to it, do we get 3? What's half of 4? And if we add 2 to it, do we get 4? So if we take half of 6 and add 2 to it, do we get 5? And if we take half of 8 and add 2 to it, do we get 6? So it looks like down here on the bottom, if we take half of 8, that would be 4, and 4 plus 2 would be 6. If we took half of 6 and got 3 and added 2, that would be 5. If we take half of 4, that would be 2, and 2 plus 2 would be 4. How about this one? Does it work for this? So it seems to work, right? So we would say, does the graph represent the equation? We're going to say yes, it does. And here's our evidence. All right, so I think we have a good start on how to graph and recognize linear equations. So on your Jamboard, I just want to remind you that your Jamboard, you want to go back to the first slides. So slides 1, 2, 3, 4, and 5 are all your homework. So finish that up and hit the submit button upon completion.